The autoregressive decoder, that is, the transformer that predicts next token like ChatGPT, ends with something called the language model head. This head is comprised of a linear layer and a softmax. The linear layer is a fully connected neural network layer. Its primary function is to map the model's internal representation, which is in the dimension of the model, like 512 or 768, into the vocabulary dimension. The vocabulary dimension corresponds to the number of tokens in the model's vocabulary, for instance, 30,000 words or 50,000 words in the case of GPT-2. It depends on each model. Following the linear layer, we have a softmax function applied. This softmax function is crucial because it converts the raw output scores, also known as logits, from the linear layer into probabilities. Each value in the output of the softmax layer represents the probability of a particular token being the next word in the sequence. The combination of these two components enables the model to select the most probable next word in a sequence, given the context provided by the input sequence. This process is repeated iteratively in an autoregressive manner to generate text, one token at a time. We've seen so far the way the input is processed and given to the encoder. After that, we reviewed attention module, the feed-forward neural network, the skip connection, and the layer connection. Finally, we saw how that information is passed through something called the language model head. So let's put all this together in a simple function that we will call the encoder block. In this code, called the encoder block, we will receive the embedding dimension, the internal values of the feed-forward neural network, the number of heads, and a dropout rate. We will create the attention modules based on the multi-head attention class that we had defined previously, followed by the multi-layer perceptron, meaning the feed-forward network. Then we have two layer normalizations. In the forward method, we do a normalization for the input, then we pass this input through the attention heads, and finally we add the skip connection and we arrive to our intermediate input. Then we pass this output of the attention mechanism into the feed-forward network. First, we pass it through a layer normalization, then we go through the feed-forward neural networks, and at the end, we add it again with the skip connection to get our final result.